Okay, today we're going to talk about functions in Python. And when you started up Python at the very beginning, you already had access to a bunch of built-in functions. You've used all of these. Int, which produces an integer from any input if it can. Float, which produces a floating point number or real number from any input if you can. str, which can turn anything into a string. And type, which asks what kind of thing am I looking at. So they all have the fundamental property that mathematicians require of a function. If you put in the same input, the output of the function will be the same time. That is, if you give the same input to the int function 10 times, all 10 times, you will get exactly the same result. There are a lot of common mathematical functions which are not immediately available but can be obtained easily. The square function which takes square roots, which is sqrt, is one of these. To use this function, you must do two things. First, you've got to import the math module. Second, you've got to refer to it as math.sqrt. So in CoCalc, I want you to do four things. Try to take sqrt of 2. Import math. Try to take sqrt of 2 again. And the fourth thing is to calculate math.sqrt. Okay, so go over to CoCalc and do all of those things. And I've got a CoCalc notebook. I haven't created the notebook yet. I'll create it right now. So let's try to calculate the square root of 2. sqrt parentheses 2. Shift enter. It says, I don't know what sqrt is. Okay? Well, that's because it's in the math module and you haven't imported it. So let's import math. Okay, so I didn't get any complaints, so apparently that worked. So now I should be able to calculate the square root of 2. So again, I say sqrt parentheses 2, shift enter, and it still doesn't understand what I mean. And the reason why is that I have to refer to it as math dot sqrt parentheses 2, shift enter, and that worked. Okay? So again, the things that you have to do, you have to import the math module and you have to refer to the square root function not as just sqrt, but as math.sqrt. So I want you to refer to the documentation for the math module here, and after you look at it, compute some of the following things. We're going to do some exercises. So let's look at that set of notes. Well, it's the reference documentation on the math module. And here it is. It lists all of the functions available in math. And you could scroll down through here and you could look at all of these things and you could find the function that you're looking for. Or you can probably save yourself a lot of time by looking up here. There's an index and it allows you to go to a particular section of this documentation. So let's suppose I know that I'm looking for a power or logarithmic function. I could go here. And it tells me what all the things are that are found here. So here's math.exp. That's what you normally see as e to the x. And it also makes available e as a constant, which you have to refer to as math.e. And then there's a logarithm to any base. It has a basic argument x and an optional argument. That's what this square bracket means. So if you if you don't put anything in, if you don't give it a second argument, what you'd be doing is calculating the value of the log to the base e, or what you sometimes see as the ln. And if you wanted the log to the base 10, which is real common, you'd say math.log10 of x. So let's go back to our exercises and see what we want to do. Oh, I want to calculate the log to the base 10 of 23. How would you do that? Take a few minutes and think about how you calculate the log to the base 10 of 23. Oh, stop the video, of course, and do this over at CoCalc and see what happens. Okay, you're back. I assume you've started the video again after doing your work. And after importing math, and you only have you only have to import math once in a session. I just did it here so that you could realize that you can only say math dot something after you have imported the math module. And here I use the general log function and I supplied the base 10. Okay. So, next exercise, compute 2 to the 3.7. Again, stop the video and go look at the documentation and see how you calculate a power using the math module. Okay, you're back. I assume that you did that. And the answer is math.pow 2, 3.7, and this is what you get. Okay, the next exercise, compute the radian measure of 75 degrees. So again, go over to the documentation and find out how you convert degrees to radians in Python. Stop the video, go do it, then come back and start the video again. Okay, you're back. I assume that you stopped the video and you did the work, and the answer is math.radians of 75. So 75 degrees is 1.3 something radians. Okay. Compute 10 factorial. The factorial of 10 could be loosely defined as the product of all of the integers from 1 to 10 inclusive. So stop the video, go read the documentations, and figure out how to compute 10 factorial. You could almost guess how to do it without looking at the documents, but look at the documents to make sure that you know that you're doing the right thing. Stop the video, go do the work, then come back. Okay, you're back. So let's look. The answer, which you might have guessed, is it's math.factorial of 10. And gosh, that's a big number, 3,628,800. Woo! Wow. Really gets there fast. Compute 2 times pi. And you'll find that there is a way to ask for pi in the math module. But go find that. Look in the documents. And come back and we'll talk about it again. Okay, you're back. I assume that you got all that done. Not much to do. And the answer, the way you get the value of pi is math.pi, pi. Okay? So the next step is to read Chapter 3 of Python for Everybody, beginning with adding new functions down to parameters and arguments. And then copy the code for print_lyrics into a cell in CoCalc and run it. And did you see anything happen? Okay. Stop the video, go do your work, and come back, and then we'll talk about it. Okay, you're back. So let's look at Python for Everybody. And I have already scrolled down to this part, and I'll just take this code right here and copy it. And I'll go over to CoCalc, and I'll stick it into a cell, and I'll run the cell. And the question is, did anything happen? No, nothing happened. That's important. Defining a function does not execute it. Several things to notice about defining functions. First, you always begin with def, D-E-F. Then there's a name, followed by parentheses, which may contain nothing. In this case, the name was print underscore lyrics, and the parentheses didn't contain anything. That line ends with a colon, and the following lines are indented and define the action performed by the function when it is called. Exercise, do a few things wrong to violate these rules and observe what happens. Okay, so go mess things up and then come back. Okay, you're back. So I assume that you've messed things up pretty well. So let me go over here and mess things up a little bit. How could I do something wrong? Well, one thing I could do wrong, I could leave out the colon. And let's see what happens. Invalid syntax. It didn't like that. Okay, well, I'll put the colon back. And make sure everything is working again. Yeah, it's working now. And maybe what I did was instead of saying def, I said daf. Let's see what happens. Invalid syntax again. Okay. So, what else could I do wrong? Let's go back. Let's fix that. Let's change daf back to def. Shift Enter. Now everything's working okay. And now, what I'm going to do, I'm going to fail to indent the first line. Let's see what happens. Indent error. Expected an indented block. After it saw that colon, it expected the next line to be indented, so it didn't like that. So let's go back here. Let's put this thing over. And you can see that it changed color. The Jupyter Notebook is helping you detect when you've got it right. Okay. Let's fail to invent this one. Well, let's make sure that it's working right again. Okay, now let's fail to indent this one. What do you think is going to happen when you fail to indent this one? Notice that it changed color when I got all the way back out to the beginning of the line. And now if I hit Shift Enter, what happened was that the second print statement was not included within the definition of the function, so it actually got executed because it makes sense all by itself. So now if I go back up here and I got it indented again, now it's part of the function, so it doesn't print. Okay, so I've messed up enough things. So what happens, of course, as you saw, depends on what it is you messed up. And just remember not to freak out when error messages occur. Look at them, and a lot of times they don't make a whole lot of sense, but you can see that something went wrong. And maybe there's a good clue there that'll tell you what it was that went wrong. So this simple function was just to allow you to display a message multiple times without retyping it every time. That's all it did. Most functions have parameters. That is, what the function does depends on what is inside the parentheses here. So for instance, here's a function which computes the area of a circle, and it has to have a radius to work with. And what it does internally, it computes area is math.pi times the square of the radius. And then there's this thing here, return area. That's what gets produced by the function. Okay? If I call the function, I have to supply a value of r. So the exercise now is to enter the function above into a cell in your notebook, then call it in two ways. One, just use the function as a command. Two, obtain the value computed by the function. Put the call to the function on the right side of an assignment statement. I want you to Observe what happens when you do both of those. Okay, stop the video, do the work, then come back. Okay, you're back. So let's see. Let's just go back and let's copy this. Copy that. Go over to the notebook and run it. Okay, I'm going to define the function. So again, when I shift enter now, what's going to happen? Nothing. But now I can ask CIRCLE underscore A REA 2, and I got the answer. Because this is simply an expression, so it executed the function circle underscore area, and because it wasn't put anyplace, it since I didn't store the thing, it actually printed. Now if I said A equals circle underscore area of 2, what happens? Well, that didn't print anything. On the other hand, I have access to the area of the circle. It's stored in the variable A, so I can ask for it, and I get the same answer I got before. So those are the two different ways to use a function. One is to use it basically as an expression or command, and the second way is to use it to put the result of computing the area into a variable. Okay. So we did this, and here is the answer. This time I called it my area instead of A. So your next assignment is to create a function FAHR of C. It computes the Fahrenheit temperature for a given Celsius temperature. I want you to use it in both of the modes above to convert 95 degrees Celsius to a Fahrenheit equivalent, the correct temperature for brewing coffee, if you're curious about why. 95. Okay, stop the video, do your thing, then come back. Okay, you're back. I assume you've done your thing, and you scurried around and figured out how to convert a Celsius temperature to Fahrenheit, and the formula was 9 divided by 5 times the Celsius temperature plus 32. Computed that as T, and then you return T, and then you print Fair of 95, and what I've got is 203. So that was just basically using it as a command or an expression. And here I captured the result in a variable called coffee underscore temp, and I print coffee underscore temp, and I get the same thing. Okay? Just two different ways of calling the function. Fruitful and void. This is an important distinction that you're going to have to keep track of as you encounter many functions and methods in the future. If a function returns a value, we call it fruitful. There are some functions which don't return a value. They're still useful. The function print, for example, does not return a value. It just does some work for you. So what I want you to do is to take the function circle underscore area, which we just created. Right now it's a fruitful function because it has a return statement. That's what makes a function fruitful. It returns something. Without the word return, a function is void. So take that function delete the return statement, replace it with a print statement, and test it with an input of 2. Okay, stop the video, do your work, and come back. Okay, you're back. I assume you did your work. So you notice that now the return statement is gone. I computed area, but instead of returning area, I printed area. And now I call circle underscore area of 2, and I got the correct value, what I got before. Okay, now here's the important thing, something you're going to run into. Try to use this function, which is void. It doesn't return anything. There is no return here. What happens if you use this function on the right side of an assignment statement? What is the type of the variable, misspelling error there, sorry, on the left side of this statement? Okay, go ahead and do that. Stop the video, do that, then come back, and we'll talk about it. Okay, you're back. So I assume you've done your work. So this is the thing I asked you to do. This function has been made void, does not have a return statement in it. So I compute my area equal circle underscore area of 2. And the function executes. Note that it does the right thing. It prints out the value that you wanted to see. That's because that is inside the function when it gets executed. When you execute this thing, all of the code within here is executed with the value of 2 replacing r. And there's the result of the print statement within the function. But now I tried to put the result value into my underscore area. And I want to know what kind of thing is my underscore area. And it's not a float. Its class is none type. That's a weird class. Print my underscore area, and the value that you get is none. So when you have a function that returns a value of none, the problem is that it's a function that didn't return anything, and that's what Python does when you try to get returned values from functions which don't return values. It doesn't complain to you, it doesn't scream this is an error, you can't do that. It just gives you nothing, or none more appropriately. Okay, so that's the end of today's lecture.